Welcome to Unit 2 of Principles of Economics. Under this very unit, we are going to talk about 6 different sessions. Where it is basic processes in algebra, graphs and concept of slope, equation of linear functions and solutions of equations in one variable, simultaneous linear equations, and we're going to also look at economic data. And remember, in Unit 1, you were introduced to the scope of economics and fundamental economic concepts. You realize that the problems that economics seek to solve are difficult ones, and you might also have realized that economics is concerned with the relations between various parts of the economy. It is interesting actually to note that many of these relations in economics are quantitative in nature. And additionally, all branches of economics make use of diagrams, and it is important, therefore, to be able to inquire into general or basic mathematics and how to interpret diagrams correctly. That is the purpose of this particular unit. That is why we are going to look at 6 different sessions that takes us through processes in algebra, graphs and concept of slope, equations of linear functions, solutions of equations in one variable, simultaneous linear equations, and economic data. So by the end of this session, you should all be able to explain and distinguish between variables, constant, and parameters. You should be able to solve problems involving algebraic expressions. You should also derive equations of linear functions. You should also be able to draw graphs and identify the slopes of linear functions. And you should also be able to solve linear equations in one variable. Not only that, you should also be able to find solutions of simultaneous linear equations and classify data by type of variables. This particular session, which is session 1, we are going to be dealing with basic processes in algebra. So as the name goes, it's very basic processes in algebra. And we are going to talk about what algebra entails, the very basic things in algebra, and look at one or two things, maybe some operations in algebra. So by the end of the session, you should be able to distinguish between variables, constants, and parameters, and you should also be able to identify basic algebraic vocabulary, and you should also be able to expand, simplify, and factorize algebraic expressions. Let's get started. What do we mean by variables, constant, and parameters? Now, when we talk about a variable, so assume I have something like, let me write x. And x is a letter, but in mathematics I can say x is a variable, which can be assigned to any number. It can be, let's say, 1, 2, 3, 4, right? Okay. So long as x can change, we say that x is a variable in the sense that it can take on different values. So when we say a variable, we are talking about when a measurable quantity, a quantity that can be measured, a measurable quantity can take on different values. That is what we call variable. Now, variables actually in economics in particular include price. So in economics, we are going to be dealing with price. You see, we'll be hearing about equilibrium price. We are going to be dealing with profit. We are going to be dealing with revenue. Let's say total revenue. We are going to be dealing with cost, fixed cost, variable cost, total cost. We are going to be dealing with interest rates. We are going to be dealing with income, which is normally represented by Y. We are going to be dealing with investment, normally represented by I. We are going to be dealing with imports. We are also going to, let me bring comma here. We are going to be dealing with export, normally represented by X, and other variables. And they are mostly represented by different kind of symbols. All right. Now, in complete contrast to what a variable is, or to a variable, are measurements of, say, the speed of light. The speed of light is a fixed, we get a fixed value. We normally say it is, the speed of light is 3, say it's 3 times 10 raised to the power 10 centimeters per second. So that is it. That is the speed of light. Now, this thing I have written here is not a variable but a particular or specific value. In this case, we say that this is a constant. You see that it is a constant. This is a constant. All right, so variables actually frequently appear in combination with fixed. It appears in combination with fixed numbers such as say 2p, right? Now here p is a variable, 2 is a scalar multiplying the p. All right. We can also have something like 3.5 r, meaning that 3.5 is multiplying the r. 3.5 r. I have 3.5 r here, and I can say even 5x. I can say 5x to obtain a particular algebraic expression. So the numbers 2, 3.5, and 5 are often referred to as the coefficient of the variable. So I wrote 2p, I wrote 3.5 r, I wrote 5x. Now this 3.5 and 2 are the coefficient of p, r, and what x respectively, and they are constant. Note that the coefficient may be symbolic rather than numerical in order to obtain a higher level of generality. For example, we could use expression, say you can say a multiplying p instead of 2p. Some economists may give a symbol like the symbol a, the distinctive name parametric constant, or simply a parameter. So in a cons we can say a is a parameter. All right. And parametric constants are normally represented by the symbols a, b, c, or their counterparts in Greek alphabet. So instead of using let's say a times p, b times a, q, c times a, z, we can say alpha p, we can say beta q, we can say gamma, we can talk about gamma, we can say gamma z, we can say gamma z, or we can even bring the lambda. This my I didn't write my lambda well. Let me clean it and write it again. Let's write lambda is like this. Lambda is like y 10 down. You can say lambda, let's say w. Alright. Lambda w. Okay. So instead of using the ABC economics, we use either alpha, beta, gamma, and the likes. And you will know some of these Greek alphabet as we go on. Let's talk about algebraic vocabulary. What do we mean by algebraic vocabulary? Now, if numbers represented by symbols are combined by any or all of the operations of addition, subtraction, multiplication, division, my division sign seems I have to get it done right. Okay, so we want the division sign, all right, and etc. If numbers are represented by symbols combined by any of these operations, then the resulting expression is called algebraic expression. So what we are talking about is, assume I say 2 plus, let's say 2x plus 3y. This is called what? Algebraic expression. It is called algebraic expression. And it's not always the case that we should bring the addition. Now, even when I write something like, say, 5x, we should be able to note that this is. So when I write 5x, you should be able to note that this is also an algebraic expression. Now, note that 5 times x is what gave me what? The 5x. So the multiplication sign is also involved in this. 5 can be said as a constant, or it can also be said as a coefficient, coefficient of x. Now here x is the variable, all right? X is the variable. Now, in algebraic expression, what you should also note is what we call like terms. So I assume I have something like a 2a minus 2a. Let's say I have 3a and I have 7a. Now take note of this. Now what is the exponent of a? The exponent of a here is 1. The exponent of a in all these parts are also 1. Now, because the exponent of a is 1 for all of them, no matter, now we can say this is being multiplied by 1. 1 times any number is the number itself. So we can say these are like terms. We can say, assuming I see A represents oranges. A represents oranges. Now it means that this my first A is 1 orange. This my minus 2 is like I say Kofi owes 2 oranges. This 3 I can say Amma has 3 oranges. This 7A can be like Kwesi has 7 oranges. Now remember, oranges is repeating itself, right? So they are like terms. How about I say A exponent 4? I say A exponent 4 and I say 2b and I say 3a squared and I bring something like minus b squared. In this case, the exponent of this a is 4, the exponent of this a is 2, the exponent of this b is 1, the exponent of this minus b is what, 2. The exponent are not the same, hence here we see we have what, unlike terms. Alright. Now we'll talk about what the square roots and the cubic roots also stands for. Let me, in mathematics, if I have this, it is the same as x exponent half. If I have cubic root of x, is the same as x exponent minus 3. The actual notes, this is under indices, this falls under indices. You have something called indices. Those of you who are doing basic mathematics, you see that we have a session on indices which explains this very well. The general rule for this is that when I have nth root of x, it is the same as what? X exponent 1 over n. For square root, we don't write the 2, we don't write the 2 here, you don't write it there. But for all other roots, maybe third roots, a cubic root, fourth root, quartic root, that's the fourth one. We bring the number there, alright. And this is what it means. So I can have something like nth root of x exponent p. This is the same as x exponent p divided by n. Take note of that. Now we will solve some few questions on indices. I'm just going to talk about, let's say, 3 laws of indices and we solve some questions. One basic law of indices is that when I have a number multiplying another number, let me write here. So a exponent n times a exponent m. Since the bases are the same, the law of multiplication in indices says that add the exponent. So I'll add the exponents. So for example, I have a exponent 2 times a exponent 3. This gives me a exponent what, 2 plus 3, which is equal to a exponent what, 5. The bases were the same, that was why we added the exponent. We can do the same for division. Now, if when multiplying we add the exponent, then when dividing, what do we do? What is the opposite of addition? It's subtraction. So when dividing, we subtract the exponent. So for example, I can say x exponent. So I can say x exponent 5 divided by x exponent 6. In this case, I have x exponent 5 minus 6. It gives me x exponent minus 1. This here leads us to another law of indices. One law says that if I have a exponent minus n is the same as 1 over a exponent n. So it means that this is the same as 1 over x exponent 1. Any number exponent 1 is the number itself. Alright. So let's now talk about some simple algebraic manipulations. We're going to be dealing with addition and subtraction of algebraic terms. Addition and subtraction of algebraic terms. Similar terms are terms that actually differ only by their numerical coefficients. You will understand when I put some question there. For example, I can have something like 3x squared y and 9x squared y. So here is the same as here, but the coefficients are the same. So the terms are the same, but they only differ in terms of what? Coefficients. Similarly, we can have something like just say minus 8x, and I can write something like 5x. Now these are also the same, x and x here, but the coefficient are different. All right. Only like or similar terms can be combined by addition or subtraction. That is what you should note. We can only add or subtract like terms. For unlike terms, we cannot add or subtract. Note that in adding and or subtracting the like terms, only the coefficients are added or subtracted. So let's take for instance what we have here, the 3x squared y. Let's see if I'm adding. What we do is like assuming this whole thing is like banana. Right. So I say I have 3 bananas and then 9 bananas. I'll just add the coefficient. I can say 3 plus 9, then x squared y. So I'll have 12 bananas. That is it. Similarly, if it's for subtraction, let's say I'm subtracting instead of adding. I can have 3x squared y minus 9x squared y. Here I'm going to owe 6 bananas. Now let's take an example where we can mix. Let me rule a line here. We want to make something. I have x squared. I have x squared plus 2x y minus y plus xy minus 3y. I think I should clean it and write it again. Let me clean it and write it. So I have something like x squared minus 2xy is supposed to be plus 2xy minus y plus xy minus 3y. Now here we have to group like terms. We have xy here, we have xy here, we have y, we have y. So I'll let my x squared stand plus 2xy. Then I'll bring this another plus xy. Then I have minus y minus 3y. Alright? Then here we are going to have x squared. 2 bananas plus 1 banana will give me what? 3xy. I owe 1 orange. I also owe 3 oranges. I'll end up owing what? 4 oranges. That becomes the solution to this question here. Alright, let's go to that of multiplication of algebraic expression. Then we'll look at factorization and the session comes to an end. Now when multiplying two algebraic expressions, each term in the first expression must be multiplied by each term in the second one and their products added. I'm not talking too much. Assuming, let me put a question here for us to really understand what I'm talking about. So I have something like this, something like this. What we are saying that is each term in the first one should be multiplied by each term in the second one. So this one I can make it 2x will multiply 3x minus 8. Then my 9 will multiply what? 3x minus 8. I can go on and expand to have 6x squared. 2 times 8, I'm going to have minus 16x plus 9 times 3 is 27, so 27x. 9 times 8 gives me, I think, 71. 72 instead, because 8 times 10 gives me 8. So I have my 72. Then I can further group like terms. Now minus 16, there's cx here, I can see x here, I can add that. So I have minus 16 plus 27, or we can say 27 minus 16. That gives me 11. So that is positive, and because the 16 is minus, so like minus 16 plus 27 or 27 minus 16. So I'm going to have a positive 11. I have x squared plus 11x, then minus 72. That gives us the solution to this expression here. You can solve more examples on your own. Now let's look at how to factorize. How do I factorize? And then the session comes to an end. Try and solve this on your own and then compare with the solution in your book to see if you are right. Let's go to factorizing. I have something like this. You see here is exponent. Forgive me, couldn't get the exponent well. This one is exponent. Okay. So I'll write it again. I have 16x exponent 3y on the y exponent 4 plus 8x exponent 2 y exponent 2 minus 4x exponent 3 y. That is what we are talking about here. So now, assuming I say factorize this, what you look out for is look out for the common number that can divide the coefficient, and you also look at the common factor in this. So here, what is common here? What is common here? I can say that xy is common, xy. 4 is also 4 can go into 4, can go into 8, can go into 6. So I can bring 4, I can bring x squared out, I can bring y out. Now it means that here we'll be left with 4x y exponent 3. Then here 4 goes into 8 2 times, so 2. X squared goes into x squared 1. Y will go into y squared 1. So the x will not come here. We will just have 2y. Then I'll bring my minus. 4 goes into 4, 1. So I'll not even bring the 1. X goes into x cubed, x times. X squared goes into x cubed, x times. I have my x. Y cancels itself, and that becomes the solution. So the factorization for this is this. How about the 12a squared minus 32 AB? This one is for this. Alright? What becomes the answer? Now 2 can go into 12, 2 can go into, but here I want the highest common factor. 32 cannot divide, 12 cannot divide 32, but the number can go into 12 and can go into 32. I can say 4 can divide 12 and can divide 32. And A is found here, A is also found here. So I can have 4A out, here will be left with 3A, and here will be left with 8B. 8B. Here will be left with 8B. That becomes the solution to this question. And that brings us to the end of the session. See you in the next session that looks at graphs and concepts of slope.